Good afternoon, class. So we are going to take a look at a different kind of example today. We can still go back to the assembly process of the cabinet and some other interesting, simple stuff around us. Today, I want to introduce a more engineering example. For instance, take the simple problem of a heat exchanger, like the wall of an oven or your refrigerator, or anything where, any situation where you are, or the engine of a car, any situation where you are either trying to heat or cool an enclosure by force, either by forcing the heat to go away quickly using fins, or by passing some fluid through the wall. The fluid comes in cold and it goes out hot, and that way the internal part is kept cool. Those are things that happen in a lot of engineering applications. So very many. And this combines a lot of physics. It combines the physics of fluid mechanics, physics of fluid heat transfer, and the mechanical, not mechanical engineering, I'm talking of the idea of stress and strains. All those things are mixed together in that problem. So the problem is really very complicated. And the modern way of solving this problem is to do a solid model and carry it finite element analysis using tools such as the Fusion 360, ANSYS, and many of these things. So the first thing you need to do is to have a drawing. Usually you want that drawing to be parametric, because if it is parametric, when you can choose parameters and change the thing. For instance, here now, let us say you have 9 fins. Suppose you want to test 12 fins. You don't want to start drawing everything all over again. You want to just change a parameter and you have a new drawing. So in order to do that, Fusion 360 provides a way through the graphical user interface to do a small amount of parameterization. And we will look at that. But this particular drawing, it may interest you that this particular drawing was not done using the GUI. This particular drawing was drawn by programming from scratch using Python. And I will just give you a peek into the program. That's not our emphasis today, but just take a look. We will come back to that because there are some preliminaries that come before talking about the program. But let me just show you what the program looks like. This particular program was written in 2020, and it is this code, this Python code now, that generated that heat. So, and it generated it parametrically as I'm telling you. In order for you to understand the code and to be able to write such code yourself, it is first of all important that you know how to do the thing using the GUI. Because the way Fusion 360 works is that Fusion 360 gives you 2 windows into the graphical interface, into the graphical libraries. One is the GUI that we have been using. We have been using the graphical user interface, which is manually invoked. You just pick elements, you draw a line, you take a line element, you draw it, and you see the result. You want to draw a body, you do an extrusion. Physically, you see the result. You apply parameters. You feel a form. Okay, where is this extrusion going to start from? Where is it going to end? Which direction? Is it one side? Is it 2 sides? All those kinds of things. All those things you are doing manually can also be done parametrically and can be done programmatically in Fusion 360. And that is the kind of thing that I was doing here. And the end result of that is that it produced this particular heat exchanger. So that is the programmatic window into the graphical library. Now, for you to even do the simplest thing in the graphical library and in using the computer program, you need to understand how to do it using the manual way. So that's why our first emphasis is to make sure you understand and you are confident and you have the skills for manual interaction with the graphic library. That's what we have been doing since, and we're going to continue doing that. But today, I'm going to, I have 3 videos that will lead us to what we're going to do. The videos are very short videos. They're about between 5 and 10 minutes each. And one will show us how to create a solid and to bore a path through it, into which our pipe will stay. And then the second thing is to now put the hollow pipe into that boring. And after that, we look at the fence and we create the fence. We just do this in short steps. If we can finish in the first hour, fine. If we cannot finish in the first hour, we go into the second hour. But my goal today is that everybody understands how to do this thing, and you are so confident on it. And once you have increased your confidence and you can do this thing yourselves, we will now move on to programming. We will now use Python and achieve the same thing again. And you will see that all that Python is doing is to take the logical steps you have done, the logical steps you have taken, and now write it in code. And then the code is given to Fusion 360 and the same result. The advantage of that is that when you are simulating, you want to create several scenarios. You may want to create 50 scenarios and then put them into your simulator and see which one of them is the best. You don't want to start drawing again and again and again. If you are drawing manually each time, and anytime you make a change, you must affect everything manually. It can be very laborious. So that's the logic of using graphics. There will be other reasons why you may want to use programming. But at least what we are doing here is that we are going to understand how to use the manual method, which we have been doing, and we're going to eventually go to using the Python programming to achieve exactly the same thing. But one comes before the other. You don't start programming something you don't know what to do. All the computer is doing is that it's automating, it is increasing the speed, and it is making sure that it takes drudgery out of it. But it's not that you don't know what to do. You know what to do, but the computer makes you to do it more efficiently. So I'm going to start with the first. I'm going to start with the first video, which introduces the stuff, and then after that we will take some time to talk about it. Then we'll go through the second video.